Good evening, everyone. How's everyone doing?
Good.
Proud. Yeah, excellent. A warm welcome. So, my name is Adam Hems. I'm the lead of the Houston Azure User Group, along with my co-host Kim Vaddy and Sats, who are helping out. I cannot do this alone. It is very much a team and family effort. So, and this is very much a community. So my day job is as a cloud architect at Microsoft. Microsoft allow me to use this room. Kim is also a colleague at Microsoft as well. She has the same role. And so what we do all day is talk to Microsoft customers about cloud, which is a lot of fun, I have to say. Anyone else interested in cloud? Anyone else think cloud's interesting? A couple of hands, a bit of nodding, a bit of, I don't know, I'm busy eating my pizza. That's fine. It's all good. So we do this all day, every day, and it's a lot of fun. But what we don't get the opportunity to, when we talk with customers, is for the folks that we talk to, many of whom sometimes are yourselves, are to talk to one another and learn from each other. Right, as part of a community that doesn't exist. It's a corporate environment, so we don't have NDAs and things like that. So this is all about an opportunity for you, the audience, folks, members here in Houston and online. Hello, to learn from one another, each other in the audience. Hopefully, perhaps it's good. We assist on the whole name badging thing here to help encourage chit chat. Right, that's what we're about here to chit chat, learn from one another, and also learn from the speaker. Vin, over to you, sir.
Thank you, Adam. Right, so good to see so many people. Thanks for coming in tonight. My name is Vin Kamath. I work at H&R Block as a principal architect. I will start off with a video.
My name is Christy, an advanced voice assistant. With your tax filing using H&R Block. How can I help you today?
What's a single filer's standard deduction?
The standard deduction for a single filer in 2022 is $12,850. This amount may be increased if the filer is age 65 and older or blind. Running out of time, you can file an extension by April 18th.
Which company has the most knowledgeable tax pros?
At H&R Block, we pride ourselves in having the best and brightest of tax professionals. Our tax pros.
Well, you get the idea, right? So this is something that we built as a hackathon prototype in March of 2023. So every quarter within the company, we have hackathons where teams from all over the world participate and showcase something that they have built in 24 hours. So this is what we did back in March 2023. People loved it. It was,
They like us.
everybody had already by then. How many of you, by the way, have used ChatGPT almost every day? Most of you probably do. But back then it was kind of a new thing, right? Like it had just come out about November, December 2022. I got hooked to it. I tried to learn what it was, formed a team, and this happened. And this story is about, taking what we have here that we built as a prototype and shipping something about 8 or 9 months later in December of 2023. As you guys know, H&R Block is a seasonal company. So most of our revenue comes from during the tax season. So anything we do, we have to launch any product capabilities usually before the tax season. So let's get into it. So this talk is mostly focused on architecture and engineering lens. Not going to talk a lot of product, business things. This is all about technology and the experiences myself personally and our teams had developing a generative AI product that we could actually launch. It's in production now for the last almost 4 months now. And, basically share what we have learned, because there's so much to learn in this space and things are moving so fast. Anything that we learn, this week may change next week. So that's what we're finding. And it's really, moving at a breakneck speed, and it's just hard to kind of stay up to date. Constant challenge. So, like I always say, this is a journey and not a destination. The product that we have today is we are constantly improving it, gathering user feedback and doing all the work that we needed to do, and getting from where it is to something that's, personifies awesomeness, right? So that's what we want to do. And this is about sharing that journey. So right after the hackathon, we had 2 use cases that we wanted to tackle. And turns out there is one solution to both the use cases. And these are some of the topics that I'm going to cover. And for those of you who are probably not familiar with some of these things, it's okay. It's best to kind of absorb as much as you can in this space with so many topics. So I just wanted to share everything that I can in this short amount of time. And again, we can have follow-up conversations about it. This doesn't have to stop today. But these are some of the topics that I felt like I must share. So the first one is RAG. Some of you must have heard about it, retrieval augmented generation. It's a pattern that has become super popular since ChatGPT came along and large language models. And then I'm going to talk about content data set, guardrails, retrieval, prompt writing. I call it writing. People call it prompt engineering. Heavy word. It's just writing. I'll talk about architecture, evaluation flows, monitoring, and the most important thing to me is number 9, learnings, right? That's what I want to share. By the way, all the artwork that you see here is generated by DALL-E 3 on ChatGPT. So we had 2 use cases, like I said. First one is we have a DIY product where you can go online and prepare your taxes all by yourself. We wanted to provide a better online tax help. And the other one is improve customer support for phone calls. These are 2 common use cases that anybody in generative AI will say, can get started on. And the solution that we went with is to use LLMs, large language models like GPT-4, GPT-3.5-Turbo, implement a RAG pattern that uses custom HRB specific knowledge base. So this is something that we have internally, IP, right? We have our knowledge base, FAQs, tax topics, and we have a tax institute who also produces large bodies of tax content. This is not IRS content. This is company enterprise content. And some of this is being used in our help center in the DIY product. So this is what we had up until now, right? You had a search box, almost like a search engine. If you type in something, you get a whole bunch of search results. Now, there are 73 results that to comb through and figure out where the answer is. We also had a chat bot, if I can call it that, and it had these prompts that come up. You have to click on one, figure out, when the answer may come along. So this is how it was. I mean, it's not bad. It works. People use it. It's useful. But we wanted to go from here to something like this, where you can ask a question and get the right answer. And the answer could be long, like in this case, with steps, things like that. You can ask a follow-up question, etc. This is where I stop this and show you how it actually works. Demo time. So this is our online tax prep product. So if you log in, you can start your taxes. But right here, you have help and AI tax assistant. So this is what help was, right? Which you can still use. And this is what we built and launched. We have a bunch of, pre-made prompts here to give you kind of samples of questions you may ask. Or, you can type in a question. So I will just, for now, go with this. Tap on it. So this response, you saw how quickly it came down, is generated by the implementation that we did using RAG. So we use Azure OpenAI. We'll talk about that in architecture. And we use our custom content. So bringing them together and doing all those things that I talked about in the previous slide, this is what you get. There are other features like, you can thumbs up or down, provide that kind of feedback. You can go into history and see all your past conversations that you've had and continue a conversation that you want to ask more about. You can go back, you can start a new topic, things like that, which is pretty standard in a conversational interface like ChatGPT, for example. And again, this is a journey. Like I said, this is just the beginning. There are a lot of plans to make this the best awesome experience possible. So I wanted to kind of show you the roadmap of how we started and how we launched. So the proof of concept was, like I said, was back when we did the hackathon. We created a dev team, handpicked group of people who are curious, who have played around with generative AI a little bit, and give them an opportunity to come together and start working on this product. We defined an architecture. We had a lot of help from Microsoft, obviously. Most of our workloads are in Azure. So obviously it was natural for us to go with Azure services. And we did a product definition. There were lots of ideas. So as you can see, I marked those pain points because there was a lot of time between those goalposts. It was very, very challenging to decide what to do with this because GenAI can do a lot of things. It can summarize stuff, it can do recommendations, sentiment analysis, but it can also do Q&A, right? And it was important for us to start with something. Otherwise, you're not gonna, learn anything. We had to come up with the eval flow toolset, which I'll talk about in a little bit. Any of you heard of prompt flow? You have? Okay. So prompt flow is a evaluation flow tool that is offered by Microsoft within their Azure AI Studio. So Azure AI Studio is great, by the way. I encourage you to check it out. And inside Azure AI Studio, you have a tool called prompt flow where you can set up evaluation flows to evaluate how the LLM responses are, like how good they are, right? And I'll talk about what kind of metrics you need. And then, we started working on development and iterating over it. We had to do human testing, and obviously load testing came down at the end, but there was a lot of iterations between the development phase and the human testing phase. In order to do that, it's very hard to do. As you can see in a conversation interface, lots of things happen, and it's very hard to evaluate. So you have to have a tool set, and it can be something like prompt flow, or you can build something on your own. We decided to build something on our own because prompt flow was really not ready. Sometimes products like prompt flow take much longer to mature. I think it's still on that curve to get maturity. For example, we are all, in our company, most of us are Microsoft shop, right? Like .NET, C#, stuff like that. And we have data scientists and, Python engineers and stuff like that. But getting all that together and hosting it and using prompt flow kind of was hard when it was just private preview. So we had to build our own evaluation flow toolset, which was fascinating because that gave us the ability to do things the way we want to do, that suits what the company wants to do. And the testers, the product people, engineers can decide exactly how the tool set looks like. And this is an internal tool, obviously, that we built. And we're still using it today. There's no reason to change it. We are constantly improving it. And then, we had load testing, which was another important step before you launch. The pain point there was to decide what kind of deployment model you need. Again, I have a slide for that where I'll talk about the deployment models, and then we launched. And since then, it's been, continuous learning and improving what kind of prompt changes that we need to make, different prompt variants, configuration changes, model version evaluations, etc. Let's get to RAG. Has anybody worked on an application that uses RAG here? We have, awesome. So this is what in its simplest form it looks like. So on the top horizontal box, you have the runtime. So that's where, when you deploy your application, things happen. And you have a design time component that goes down the vertical. So let's say you have a custom content data sets that's specific to your company or enterprise. You have to run it through an embedding model. In this case, we used Azure OpenAI Ada. And you then create a content index. This is the one that you use in runtime to query the index. So as the user question comes along, you turn it into what is called as embeddings. Again, I'll talk about what embeddings are. These are basically floating point numbers, numerical representations of language. It could be words, tokens, phrases, paragraphs, doesn't matter what it is. But the embedding model has a semantic understanding of language. And because of it, it knows cat and dog are animals. A puppy is closer to a dog than a rock, something like that. So when you do that, what you can do is you can query the index and grab a bunch of passages, okay? Bear with me until I go to future slides because I know there's lots of technical terms here. But what happens is after you get the passages from querying the index, and this is called vector search. There are many ways to do retrieval, by the way. Vector search is one of the most popular right now. But I see that in future, there's going to be more ways to do it. You get those relevant content results, and then you assemble a prompt. This is the GPT input request that actually goes to the LLM, the large language model. So you take the system prompt, take the relevant content, and the user prompt, which is the actual question, and then you send it to LLM to get a response. So all of this happens in that demo that you just saw. However, the design time should happen ahead of time. This is not something that you would do runtime. So you convert all your content data set into embeddings, and you have to constantly update it. So what that means is you have to have a content ingestion pipeline. As content changes, tax law changes, for example, when it changes, you have to make sure you update it, delete the index that you no longer need, run your batch process, things like that. Please stop me at any time. Let's keep this interactive. I know it's too much information, but it is an example LLM input request in runtime. Now, again, lots of text. This slide is dense, I understand. But if you see, squint your eyes and see there are components to what goes into an LLM. Yeah.
Somebody did a Google comment console call.
Sorry?
They asked a question on the.
I got it.
Thanks.
They're asking, suggesting that we talk about training the model with your own data set. How did you learn to train the model with your own data set?
Yeah, great question. Well, the answer to that question is you don't train the model, which is very surprising, as you can think of. Instead of training the model, there are many types of training. There's pre-training, which is what companies like OpenAI, Google, Facebook with their Meta, with Llama, they do the pre-training, and it takes lots of money and many, many days. You might have heard, this model took 15 days, another one took 21 days. I mean, I don't know how it works, honestly. Like, I don't even care. Like, all I know is there's a large language model available to you. How do I use it? So that's why this is applied AI as opposed to actual AI, right? So the natural way to do this is to not think about it from a standpoint of training the model, right? Instead, think in runtime, what kind of payload that you want to send to the LLM to get the kind of response you need. So that's why you do augmentation of retrieval content. So if you look at this, the box in the orange has the relevant passages. So that's the content that you retrieved, and that's how you train the model. Now you may think, okay, why am I saying that you don't train the model. Yes, you do train the model, but in runtime. You don't train it ahead of time, right? So what that means is this is called in-context learning. So if you see the messages collection, you have two message turns happening there. The first question is, when do I need to file my taxes? The second one is, what happens if I don't, right? And then we have the third one. So the model learns from what you send it, looks at your messages collection, which is your chat conversation, and then you have passages that you send, the relevant content. So any training that's happening is happening statelessly, right? So it's stateless in-context learning that the LLM performs and gives you a response. This is the easiest way to do things. This whole concept is super simple if you think about it. Now, if you need advanced capabilities, that's when you think about fine-tuning and then eventually go to pre-training and other things, which I'm not an expert on. You had a question?
Yeah, so my question was regarding, you said like you train during runtime. So runtime would be like when I am present.
When you send a question.
When I send the question, like that session basically.
Yes.
So sometimes when I come back, do I have to restart the same thing again or it?
No, you don't, because the chat conversation, it's the application's responsibility to save. So when you save it, it's as if the model doesn't even know. It's completely stateless, right? So you do have to send the past few messages along with, if you already had, let's say, 3 message turns and you walked away, and then the next day you came in and you asked the next 4th question, then it carries through that, all these messages, just like you see here.
Like, for example, if I say, get me a picture of puppy, let's say, and it gives me a picture of wolf, and then I say, no, something smaller. And somehow it knows. So next time I come in and say, I want some picture of puppy, I would expect it to.
It will.
It will.
And the reason is, it's like I said, you have to build the application, right, that does this. And it's that application's responsibility to send this payload, which includes your past few messages. And you can decide whether to send 5 messages or 10. And this is something that's called short-term memory, because you set what that short-term memory looks like. It could be 5 messages, it could be 10 or 20. So based on, and it all impacts the token count and cost, right? The more messages you have in history, the more it costs, because that's going in every request. That's how it knows.
Let me confirm one thing with you about that.
Sure.
So if you deploy the sample apps from Azure AI Search, how it saves your chat history, are we saying that it's going to use it if you just type in the same chat the next day?
Again,
Messages.
like your application must be saving it somewhere, the chat now.
I'm talking about the sample app. If you create it using the Microsoft App Service, it saves your chat history. It's a feature that just comes.
Yeah, okay.
What I'm asking is the next day when you come and you open the chat history, do not start a new chat. It's going to use the previous messages by itself.
It's,
Do you know?
I don't know, but my guess is it's going to continue if you open up the previous conversation. If you start a new one, then it's not going to have any context.
Yeah, and I can add to that, right? That was a feature of the application.
Yes.
So that's not a feature of Azure, not a feature of OpenAI.
Understood.
Right. And usually the infrastructure is Redis cache is usually the store that is actually used to keep a track of the whatever the history that you want to keep, the state, if you will. That's usually the infrastructure used by things like web apps, and that is retrieved from.
By default, it's providing Cosmos DB. You can attach a Cosmos DB.
You can use Cosmos as well. Yeah, it's up.
That's what it's doing today.
Okay,
we tried it last.
That's up to you. Yeah, as the designer of the application, you pick the data store, but you, like Vin was saying, you need to provide it a memory, right? It doesn't come with a memory. It's completely stateless. So you have to do that as the design of your AI-enabled application. Yeah, Redis cache, Cosmos, Azure Storage, however you want to do it.
Are you going to be at some point talking about the dating of the index, the pipeline, or that's not part of your content?
It's not part of the content, but I can talk about it.
Thanks.
I'll tell you what I know.
Sounds good.
But just to add to what Adam said, if you look at architectural references about how to store conversations happening in GenAI space, and Cosmos is the preferred choice, simply because it's a document database, right? And when you look at a chat conversation, it feels like extended docs, and you get to decide how the JSON looks like.
So I've been using Azure's OpenAI to do this, but when you showed your example there, in Azure, you were at H&R Block's website. So is it making calls to something in Azure and taking the information back down, or what?
Yeah, all these services, Azure services, are of course in the cloud, and our application also sits in the cloud. And when the time comes to send this payload, just like, this is a synthetic example, not the exact one, I made it up. But when you send this request, it's going out from your application, wherever you're hosting this app, the compute, right? From there, this request goes to the LLM, in this case, GPT, OpenAI GPT, Azure OpenAI GPT. So that's what's going on. So we don't necessarily have to worry about the model. That's the service that and you pay by the tokens, right? Pay by the usage. So there are two deployment models that I'll talk about, and you get to pick how you want to spend your money. Adam, you had something to say? Or
let's see. There was a question online. Do you encounter any issues with the structure of your documentation when implementing RAG? Alex asks. He had to spend a lot of time tweaking their RAG system to get good results with zero-shot response generation.
Yes. We did have lots of challenges to get everything right. And I would say, I'll go to the next slide and talk about guardrails, which is probably the biggest deal out of everything else here, because it's the most challenging. But before I do that, I do want to touch upon a few things here. If you look at the bottom, config parameters, there's temperature, max tokens, and then top peak. Don't need to worry about too much about them. Just, think of them as configurations that help you tweak the response, the kinds of response you want. For example, top peak controls vocabulary, temperature controls, how precise or creative you want to be. You must have seen those buttons when you first used Bing Chat. Back when it came out, there was an option to pick what kind of temperature you want to set. So depending on your use case, you may decide to set a low temperature to make it very, I would say, precise and kind of robotic. But if you set a high temperature, like maybe 0.8 or 1, you'll get more creative responses, which also brings with it this concept of hallucinations that you might have heard of. I don't like the term hallucinations. You should think about them as whether the response is grounded in your content or not. So if it's not, then, it's not helpful, although it's creative. If you're a content writer and you want to generate content, that's a different use case. But for most enterprise use cases, you want to be more precise. In this example, it's a 0.5 temperature. All right, so I wrote a few LinkPad recipes. I don't know if any of you guys use LinkPad. I use LinkPad as almost like a REPL, where I write some code, execute it really fast, see how it works, things like that. So I'll switch to LinkPad for a bit. Hopefully you can see the code here. Okay. So the first step is convert your content to embeddings. Okay. So in this case, I have some content. I'll show you the kind of content I'm talking about. So I have like 6 or 7, 8 rather, 7 tax tips. I have some content that I came up with. This is already available in our help center if you go to the DIY application. And basically, I'm turning this content into embeddings. Okay, so once I do that, if I run this logic, I'll show you what happens here. So we take the content, we open up a OpenAI client connection. We create these embeddings. So these embeddings are simply a dictionary of string, which is the file name here, and a tuple, which has the floating point numbers for each of the content. So I've set a batch size for 10. I loop through all those text files. And then way down here, I call the embedding model. So this is the design time vertical box that you saw in the previous slide. So this is where we convert those content to embeddings. We add it to this dictionary and the dictionary is ready. Let me show you how that looks like. So if I open this up, so this is how it looks like. I'll just format it. So I have the content up here, and then a collection of the embeddings. So this is just multi-dimensional. So the content is taken and plotted in multi-dimensional space based on its semantic meaning in English language. The thing about this that I do is I don't worry about this stuff because like you can go deep into this and start to figure out what are embeddings and why is it minus and decimal points and stuff like that. But at some point I was like, do I really need to know about this stuff, right? Like you're doing applied AI, and applied AI is taking what's available and figuring out a good use for it, right? So as long as you know how to do things and be able to implement, I think that's good enough, right? So, it's something, my personal opinion of these things, you do need to know things like tokens and embeddings. Like you need to know the concepts, but you don't really need to go down and, understand everything about it. And you take those incremental steps to learn it. You don't have to start with it. So for example, the first time I converted content into embeddings, it was very appealing to me to go in and try to dig in and figure out what these numbers are. As engineers, that's what we do, right? But after some time, it was diminishing returns, right? Like we know how it works. Once you learn the concepts, figure out a use case to apply it. So as you can see, these embeddings go long. Like this content is here, then the next content, next embeddings, so on and so forth. Okay. So once this is done, you have to think about how to do vector search. So this is an in-memory example of vector search, okay? This is not making any calls to Azure AI Search or Quadrant or any. There are many, many vector databases available out there. Quadrant is very popular. For example, I like Quadrant. But Azure AI Search also has vector search built in. It can do embeddings. It can do all the stuff for you. It has hybrid search, which is a hybrid of vector search with semantic configuration. So Microsoft Azure takes care of all of that work for you. You don't have to do the hard work. In this case, though, just to learn the concepts, what I've done is, here is the user input query. What's the liability if I've received gifts? And what I do is I load up that JSON document that you saw that has the embeddings, and then run a cosine similarity. So, and first time when I learned about cosine similarity, it was like, what is this, right? You don't know what it is. Like, it's like a academic concept, but it's pretty simple. This is the simplest form of cosine similarity. If you ask ChatGPT, for example, you'll get, code samples, you'll get a full explanation of what cosine similarity is. But it's pretty fairly straightforward, right? Do some math and you figure out how close is your query to the available content data set, and you grab those passages. So in this case, I'm saying if the similarity score is more than 80%, then add to my results. So when I did that, I've got 81% similarity score for this gift tax, because my question was about receiving gifts, right? Now, if I said presents, it will still be able to find it, which was not possible if you do keyword search, for example, right? You can do it a little bit with semantic search, which is a little bit better than keyword search, but with vector search, you get actual meaning. So it uses its meaning to do the search. Now, it has been found that a hybrid search is better than just vector search or just keyword search or any of those combinations. Microsoft has a blog post and lots of details about this. This whole space is called retrieval, right? So lots of content out there I can share with you after the talk, but here we ran that. And the next step is the actual call that happens in runtime. Okay. So in here, we have a simple system prompt, just like you saw. You're a tax help assistant, blah, blah, blah. Here are your instructions, things like that. You load up the embeddings. Here is the question, what's the liability if I received gift? Then you call generate response async, where you assemble the prompt. This is the piece that is the real code that shows what was on the slide. Okay, so you have your system prompt, you have relevant passages, you inject the content that was retrieved, and you send it across. So here are some chat completion options that you have to set. This is where you do configuration of all these things. Max tokens is you're telling the LLM how many tokens it can use when it responds. There are a bunch of other configuration that you don't really need to worry about, but end of the day, you get a response back. And in this case, this is the response I got, which is like a human-like response. Instead of search results and long passages, the person who receives your gift does not have to report it to the IRS, but it's the responsibility of the person who gave the gift. So, simple example. Now let's think about guardrails. Here is an unrelated question, okay? Does anybody know the answer to this question? What's the largest canyon in the solar system?
On Mars.
It's on the Mars. Where is Marineris?
Largest canyon in the solar system.
Now, if you did not have guardrails, you would get that response. But in this case, I have guardrails. I don't want it to, respond. I wanted to say, I can only help with tax-related questions because you are your enterprise company that only wants to care about questions that your clients may ask. And there's no chance of abusing the system if it makes sure all the guardrails are put in place. There have been leaks early on when ChatGPT came along, when folks went ahead and implemented it. News headlines about how you can, abuse a system like this. So it's very important to pay a lot of attention to guardrails. And it's never a done task. You have to always constantly figure out, it's almost like security, right? Figure out like what kind of, things may still leak into the response. So in this case, for example, how did this happen, right? There are instructions, limit your responses to the relevant passages only. And as you may notice, there is some syntactic sugar here. You can use parentheses, you can use angle brackets, and basically you do that to provide some more meaning to your system prompt. These days, with newer models, newer syntaxes, I don't know what else to call it, right? Like structure and syntax. There's a lot of work happening in prompt engineering, which is really, really exciting. So I encourage you to take a look at that. I also wrote a simple little example here that is streaming. Everything else remains the same, but the call is token by token. So in this case, you get chat completion streaming method. Now, all of these are part of Azure AI, Azure.ai.OpenAI NuGet package. So that's like your bare metal NuGet package that you need to do the work. There's Python SDKs and other languages as well. Same concept, no difference.
Question for you.
Yeah.
Is it a future path or you're doing it now where if I have filed my taxes in 2022 on H&R's blog, I can ask my relevant information?
Yes, I'll get to that. That's the next frontier. That is personalization.
In that time, are you going to talk about guardrails to prevent answering questions about other people's taxes?
That's again application's responsibility. LLM doesn't know anything about it. So as a
You guys have implemented.
no, personalization is not done yet. That's the next frontier, right?
Okay.
So right now we're only focused on information. Okay. So and I'll talk a little bit more about the next. What's next? So there is a link here that is basically, talks about all these, code that I shared with you. This is the architecture. And I know it's again dense. I couldn't put all the boxes here. Tried to simplify it, but wasn't really successful. So from the application, right, UI, the requests go through an app gateway. And then you have an app service environment where the compute is hosted. This is where the application lives. We use semantic kernel, which some of you may have heard about. We use semantic kernel for specific purposes. We don't use it for everything. You just have to figure out what works for you. It provides lots of capabilities. So semantic kernel is like an SDK by Microsoft that is similar to LangChain, which many of you might have heard of. So it's like an abstraction on top of large language models and other pieces that are in GenAI space, where you can pick and choose what kind of capability you want, like chunking strategy, for example, vector search, and so on and so forth, right? So in here in the blue box, you got, query and retrieval, persistence. This is where you, use Cosmos DB to store your chat conversations. You can do PII anonymization. If somebody is sending in some PII, you want to make sure it's secure and private. So you want to anonymize those text content. Here is Azure AI Search, where you can do semantic re-ranking, create a hybrid index. So all your content data set goes into a content ingestion pipeline using the same approach I showed about embeddings, store it in blob storage, retrieve them, make sure the content index is in Azure AI Search. So in runtime, this dotted line is the demarcation. So on the left-hand side, you have runtime, and right side is end time. On the left-hand side, in runtime, when the call comes in, all of these things happen, and you eventually send that assembled custom prompt to the GPT model. Next thing I want to talk about deployment.
Were there any questions on that? Because that was a good one, that diagram.
Oh yeah.
Can you go back?
I mean, you can see some variations of this already with Microsoft documentation where they have architectural reference. This is one flavor.
Any questions on this, like the memory?
Yeah,
for example.
since Adam persists, why semantic kernel and not LangChain? Since LangChain is more prevalent, more known to people.
What?
Just because you want to stay in the Microsoft constraints.
Pick what works best for you, right? Like you cannot go wrong with either, is what I would say. I mean, let's say you pick LangChain, that's fine. It's like saying, C# or Java or Python or Rust or similar kind of thing. Each of them have their strengths. Semantic kernel is evolving really, really fast. So with .NET, when you got .NET developers, C# experts and stuff like that, it's easy to go with semantic kernel. That's all. Yes.
You folks are not using API management.
We do use API in many other systems, but not in this case. This is a brand new.
How are you controlling the throttling of requests and everything?
Well, first off, the throttling comes into question when you use the pay-as-you-go LLM. So when you use Azure OpenAI, there are two choices, which is what I was in the next slide, but I'll speak about it. So you can either choose pay-as-you-go model, which implements throttling, or you can use something called managed PTUs, provisioned throughput. So, it's like renting an apartment. You rent an LLM and you decide how many PTUs do you need based on your request. And, then the throttling becomes less of an issue. That's why you have to do load testing. So when you do load testing, you figure out what is the expected volume of questions that, your users may ask. And based on historical data, you figure out, okay, these many PTUs you need. You keep a little bit of buffer, and then you decide that it should cover for it.
Okay. Thank you.
So I do want to address those. So in future, I do see a situation where you actually want to use something like APIM to do throttling. But right now, we didn't feel the need to start off with it.
So then Tom online had a question. I was going to get you to expand on it as well, which is the document ingestion pipeline, the stuff on the right there. When you demoed just now, you did all in code using the SDK from your C drive, but that is not what you have up here. You have documents being fed into Azure AI Search. Could you just walk through that
Yeah, sure.
a bit? Just because that's what you did in code, but you're using Azure infrastructure for that.
Yes. So it's kind of easier to show in code to load up from local. But in this case, imagine these content sources may be in different systems in your enterprise. So you may have APIs to call to get this content, right? So when you say content ingestion pipeline, in our case, we use Azure DevOps. You could set up a pipeline which goes out and grabs this content on periodic basis, right? That's your pipeline. And then you use the Azure AI Search API reference, which is pretty complicated, but once you get over it, it's easy. You can use APIs that are provided in Azure AI Search, not point and click, go to the portal stuff, but use the API, and all of that is code. So Adam, so everything that you see on the right-hand side is code. It's just put into a pipeline.
And so the documents are retrieved, in your case, by Adu. They're dropped into the storage account. And then you have Azure AI Search, which will then ingest them into Azure AI Search. And you use the embeddings index of Azure AI Search on those. Is that correct? Because you showed us the embeddings, that JSON file that you made using the SDK in code. But here, you're using Azure AI Search to make those embeddings from your documents when it reads them from blob. Is that?
I will say, though, that's correct, accurate. This is, again, a reference architecture. What we do currently is a little bit different, and it evolves very, very fast. But this architecture works and is recommended by Microsoft. So what I'm showing you here is, one flavor, like I said, of what Microsoft recommends.
Looks like you're like copying the content source data into Azure Blob Storage feed via ADO. Is there a reason you're using that over like Azure Data Factory or another?
It's just simple. It's the simplest form of, so, if architecture can get really complex as you add more boxes. So this one is like limiting and keeping it simple. And blob storage is, personally one of my favorites. It just works. There's no reason to like make it more complicated. But eventually, yeah, for data, like, your user conversations and their feedback, and so you can use Azure Data Factory, sure. So to answer your question, these are the two available deployment models, which I already talked about. So load testing in production, it's kind of recommended to go with managed PTU. So if you step back and think about the problem spaces in RAG, there's user input classification, retrieval, and generation. The first one is kind of optional, right? Like if you don't want it to be super efficient and are okay with just doing 2 and 3, it works, no problem. But you can decide, depending on your use case, that you want to do user input classification. For example, you don't even want it to get passed to 2 and 3. You want to stop it right there in the tracks. Let's say there is an unrelated question being asked. You want to implement a bi-label classifier to take it out of the pipeline. You can do restatements. Sometimes questions are hard to retrieve and generate. So you can restate the question being asked to suit your context using LLM again. So that's one more extra hop. You can also do metadata filter queries. So if there are numbers and queries that you want to send to the retrieval process, then you want to take that user question and break it down, do some entity extraction, and create these metadata filter queries. All of these are, again, new concepts that are coming up. Yeah.
What's the bi-level classifier? It briefly explain.
I'm sorry?
What's the bi-level classifier?
Let's say you have a question, like I said, what is the largest cannon in the solar system?
Okay.
You don't want to answer to that. You don't even want to go to step 2 or 3, right? The most optimized way to stop it right there, classify it as unrelated, and send a static message back, right?
It is the same model that you're using, or it's a different model?
Where?
In bi-level classifier, restatements, matter. This is all Azure OpenAI.
No, this is build your own.
Say, do you care to share what is it that you're?
Right now, it's in a research phase, so we are not to a point where we not share anything.
It's outrageous.
In the retrieval phase, there are so many concepts to learn and understand, like vector search, hybrid search, the similarity score algorithm, content gaps that you want to find out. So there may be questions that you genuinely want to have the system answer, but maybe you don't have content. Like, how do you figure that out? Detection of those gaps is also very important. Chunking strategy. Microsoft has so many, Google has many documents, papers written on this stuff, chunking strategy. There's also documentation by all the big players. So there are different ways to do things. You have to take it and figure out, okay, for my content data set, what is the best strategy? Is it, 512 tokens with 25% overlap, or is it 10% overlap? It's hard to say. You have to start somewhere and test it. On the generation side, you have prompt engineering, of course. We talked about guardrails, configurations, choice of model, and version. The other thing I wanted to share is version of the model is also important. So even within GPT-3.5-Turbo, for example, new versions keep coming up, and each version may work slightly differently. So the test cases that you had written earlier may no longer work in the new version. So it's very important for you to run through your evaluation flow each time you upgrade a version, for example. When I say model, I mean the difference between 3.5 Turbo and 4, or Llama 2 or Gemini or whatever else you're using. The version is like a version within that model that you use. So in 3.5, you have multiple versions. In 4, you have multiple versions. For example, the latest one, the 125 in GPT-4, is a fantastic model. I highly recommend you guys to check it out. There's also things like your, content filters and jailbreak prevention that you need to worry about. So I don't know if you guys have noticed, but there is a way to jailbreak things, in the prompt engineering world. And Microsoft provides just a checkbox that you can check and say, I want you to prevent any jailbreaks happening. They also provide content filters, and they, stop all the abuse of the system. So these capabilities, some of them come with the Azure OpenAI service, which is why we use it, because we don't have to build all of this stuff. So within prompt engineering, pick up prompting frameworks such as CoStar is one of my favorites. There's TIDD, whatever, CARE. You will see, if you go to LinkedIn and follow generative AI, you will see so many different frameworks for prompt engineering. Pick one that works for you. Consider using Markdown for system and user prompts, because Markdown kind of provides more meaning to your prompts. Make sure you have a persona, tone, do's and don'ts, variables. You may decide to use variables and inject in runtime to replace those variables. The structure of the prompt is also important. There is a concept called reinforcement. If you really want the model to behave in a certain way really, really badly, you want to repeat yourself. So you start off with that statement in the beginning of the prompt, then you add it to the somewhere in the middle, and then you end it with that reinforcement. So that's an example of how you want to play around with the structure. Then you have a bunch of instructions, right? These are instructions about response format, what are the things that it must not do, and things like that. Talked about reinforcement. The prompting techniques have been evolving very, very rapidly.
Ben, yeah, we've got a question on the previous slide.
Okay.
And the one before that. From section 2, Alex asks, can you share any lessons learned while developing your chunking strategy that you've got right there? How did you develop a reliable strategy, and any insights you can share?
Sure. So chunking strategy is a challenging topic because there's no real way to, know what the best chunking strategy unless you test it. And we started off with a default, right? And then when we saw research papers, and you look at research papers, you look at blog posts and articles and documentation, lots of research is required. One of the strategies that was recommended is when you use hybrid search, for example, with Azure AI Search. There was a recommended 512 tokens with 25% overlap or something like that. I don't remember the numbers exactly, but there was recommendations like that. So when there are recommendations, what we do is we take those recommendations based on time and runway, and you test them and see if it works, see if it produces better responses. And the only way to do it is to have, depend on some tools, right? Like prompt flow I talked about, or build your own. That's the only way to do it. So you have to start with default, some default. 10% is a good default overlap, for example.
So your evaluation is subjective rather than objective. Yeah. Once you,
it is subjective because you have to have humans in the loop who are experts who can validate your the LLM response. But you can also automate it using LLM itself. So for example, GPT-4 is really good at scoring. So you can say, here's my question, here is my ground truth, and here is the response you got. Now score it from 1 to 5. So LLM can do it. So prompt flow lets you do that. There are different models that can be used for evaluation. LLM is just one of them.
in terms of responsible AI, what is it that you are, Azure OpenAI, responsible AI, big deal nowadays. Everybody is supposed to be using it responsibly. What is it that you are using, such as guardrails, jailbreak prevention, etc., etc., etc.? Explicit language prevention. How do you filter? How do you check for that?
So you have to abide by legal and compliance. Obviously, that's the first step. The next one is security and privacy, right? And all of those apply to any applications that you ship. So in the case of using generative AI, you have to depend on something like Azure OpenAI, responsible AI principles. So we just follow them, so to speak, and we put our own on top of those principles. Because, that's the best way to do it, I feel like, because responsible AI is a very long topic, and it's already been discussed so many times. So what you have to do is based on what your enterprise believes in, like what the privacy and data practices that you have in InfoSec policies, you just have to make sure you abide by them on top of what your cloud infrastructure already provides. So that's the approach, I would say.
Yes.
Okay, so I did want to show you the evolution of prompting techniques. These are all fascinating. I've used some of them, not all of them. The latest one being graph of thoughts. You must have heard chain of thoughts, but right now, graph of thoughts is the latest one. There's more coming out every day, so it's hard to keep up, but I did want to share this. Here is an example of kinds of things that you want to test. You want to test for groundedness, relevance, adversarial. This is where you include prompt injection and prompt leaks, guardrails, and coherence. This diagram on the right, I just put it out there to kind of talk about the scoring approach I talked about earlier, like from 1 to 5. Of course, with decimals, if you want to be precise. But these are the example metrics that you want to use. There could be more. There is recall, a whole bunch of classic machine learning metrics that you want to test. But generative AI, applications usually start off with these 5, groundedness being the top one here. This is an example of a good challenge. When you run your vector search on how to claim adoption credit, again, this is a synthetic example, you may get these 5 results, and you want to send all of them to your LLM to say, okay, now construct a response based on this information, right? If you look at result 2 and 3, they are semantically similar, keyword is similar, but they are unrelated to the question itself, right? Adoption, child, education, all of these are kind of, seems relevant. They're part of the result, but they may not be actually needed for the LLM to respond. So how do you solve it, right? You don't want to send and get a jumbled up response because you send, results that are not really relevant to answer this question. So it's a very challenging problem, and it can be solved, right? It's a way to figure out. I just wanted to show you, like, what are the kind of challenges that will come up, right, as we evolve and try to figure out how to solve these problems.
You solve it by having it ask another question to narrow down the first one asked?
Exactly. That's one of the ways to solve it. Like, or you can develop a prompt that only focuses on result 1, 4, and 5. So you have to do some really deep prompt engineering to make it understand that, hey, this question is only about adoption credits. Although you may see other polluted results, you have to ignore them, you have to pick this, and you have to test it. And what you can see there is it doesn't always work. It's non-deterministic. So that's another challenge, right? Like, the LLMs are not really deterministic, so you have to, the reliability comes into question. So the other option that I do want to share with you is you may build your own model, right? Your machine learning model that can do this job ahead of time. So before you get to LLM, you can do additional processing where you can use a smaller model, machine learning model, that can, reject some of the results and just give you the filtered version of the results. So there are many techniques like this so the whole point of sharing this is to start to think about what kind of, problems you'll run into when you just implement RAG. It just doesn't work when you start off. Like, simple examples work, but as you get deeper and deeper, you'll realize all kinds of new challenges. So key takeaways, things that we learned, right? Don't sweat small stuff. Like, there's all kinds of very interesting stuff that you can spend time on that in hindsight you may realize are not really worth it. Things like temperature, top P, and a whole bunch of configurations. Testing takes time. Tooling, content, app improvements, they take longer than actually building the system. So the development does not take that long. It's all the other stuff that takes the longest possible time, and sometimes causes frustration also, right? Like, you don't know what to do about it. Automated evaluation flows, human in the loop testing, that's all labor intensive. And
So let's say the human tester takes the result and says, no, this is not right. It should be something like this. What do you do with that?
Great question. So every time that happens, you have to use that feedback as to what is the right answer for this question. You have to figure that out. And with your, domain specific knowledge, you have to come up with a response and either augment the content, or you figure out, is it a prompt problem? Is it prompt engineering problem? Is it a retrieval problem? And that's why I shared with you those 3 problem areas. So is it the user input classification? Is it the retrieval? So you have to classify them. And this is all engineering work. There is no silver bullet. And you have to basically figure out, okay, this is a retrieval problem, right? The content doesn't exist. Or, the methods and tools we are using to do the retrieval are not optimized. And every time that happens, you have to put in the work. There's no other way. Highly recommend reports and data from day one, because this is the feedback that you need. This is also called model monitoring. There's lots of, discussions about which model is the best. If you ask me, just pick a model that is, industry leading and stick to it. Because most of the work that needs to happen is in your space, not the LLM. So if you pick a reasonably good model, any of the leading models, including things like Mixtral or Gemini Pro or Llama 2 or Azure OpenAI, whatever, right? Just stick to it, because they are all reasonably good. You can't really go wrong with any of those, right? Some may require more work than others, but I don't think there is a huge difference between, and they keep changing. You will see benchmark results that come up, pretty much every month now, that says, okay, my model is better than yours and this and that. And,
Which one are you using?
OpenAI.
But no. OpenAI, which version, Turbo, 3.5? Or...
We use 3.5 and 4, depending on use case. We use both.
In which case do you prefer 4 over 3.5?
4 costs more money.
Yeah.
So it all depends on what are you using it for and is it really worth it, right? So if you need advanced reasoning capabilities and don't really care about the performance that much, then 4 is a better option. 3.5 has fantastic performance, but it's a lower level model compared to 4.
And in terms of development, are you using standard Visual Studio Code, dev containers, anything like that?
Not dev containers, but everything else, yes.
Okay.
Another thing that I do want to share is the UI and UX is really important for any generative AI apps. ChatGPT is the greatest example of that. The reason it worked is because it turned the capabilities of LLM into something that humans can reason about, having a chat conversation, which is just natural. People use iMessage, WhatsApp. It's just chat is just natural. So the UI paradigm is really important. And every use case may require a different UI and UX. Like, don't always think chat is the only way to use generative AI. There could be other ways to use LLMs. Think human-like, right? You want responses that are human-like, as if you're feeling like you're talking to a human, not a chatbot. Well, what is the difference? Chatbots have been there for many, many years now, and they work in a Q&A fashion. They don't know the context. They don't know the message history, where you came from. And it's kind of very laborious to use. They're just not natural. So moving from chatbot to a human-like assistant is really important. And you do want to test internally first, obviously. Get some real users who love to play around with this kind of stuff and get their feedback with different departments, for example, maybe marketing, product, other areas where you will see blind spots that as an engineering team, you may not see.
Sorry, Vic.
Yeah.
Your presentation is really good. That's why I'm asking a bunch of questions.
Sure.
Are you differentiating between chat and Copilot, or it really doesn't matter to you?
I would say conversational UI is the better term. Chat is a simpler language. But Copilot is something that probably has more meaning to it because it can probably do things, for example, Bing Chat, right, which is now renamed to Copilot, can use a browsing tool to look up information over the web and give you a response. So to me, Copilot is a word that can be used when you want to do something more than just sharing information.
I was thinking more in terms of X Copilot, right?
Okay.
Which is for your users, end users,
Uh-huh.
people who are preparing the taxes, and they need to questions with reference to the UI, tax UI forms that you're using. Are you doing something along those lines, or you're not?
Like I said, right now the AI tax assist is focused on providing tax help around topics, which is more information. The Copilot concept, everybody is looking at it. So I'll go to the next slide where I talk about like what is the next frontier in generative AI space, and that is one of them. So this is another learning, right? You have to make decisions and keep going because, there are many, many different ways to build a GenAI app. And taking quick decisions and taking reversible decisions is really important. Prompt engineering is harder than it seems. Okay. And that's why probably it's called engineering. I call it prompt writing, but it is harder. When you start off, it seems really, really simple. And as you try to cover use cases, edge cases, outliers, that's when it becomes really, really hard. Because you try to fix one thing, it may break something else. And which is why, again, I go back to having your evaluation tool sets, because if you don't have regression testing, then you might miss something. This is another important learning. The more steerable LLMs are, the more sensitivities to your words, characters, structure, and placement. How you write prompts, right? An LLM may claim that, hey, our LLM is like super steerable. It can do whatever you want, right? But it also becomes very sensitive. So there's not a lot of room to kind of move your words and characters. So it becomes very touchy. This was an earlier question, fine tuning only if all options are exhausted, right? This is just, again, personal learning. You don't have to take my word for it. Try it and see for yourself what works for you. This is probably the most important one. Reasonable level of comfort with inherent uncertainty is a prerequisite. It's required because, otherwise, if you are saying I absolutely want this to be this way and go with that kind of fixed mindset, then you'll run into more challenges. So I would not recommend, have some, level of comfort where you say, okay, I really don't know what's going to happen. Let me see what happens. Okay, so the next, what's next, right? I'm not talking about our products here. I'm talking about what I see in the generative AI space. AI-enabled retrieval in RAG is one of those areas where the retrieval process, the second pillar, right, could become more smarter. Right now, it's not that smart. It's only semantically smart, but it doesn't fully understand like an LLM does. So maybe we'll end up a hybrid of LLM and embedding models. I don't know, but there is a need for it. It's a need that I see. Agents that use tools plugins. This is another area where things are fastly evolving. To me, co-pilots kind of belong in this space, although the current co-pilots are pretty simplistic. Like if you go to PowerPoint and use the Microsoft 365 Copilot, it can only do a couple of things, right? Not everything, but they are constantly evolving. They use tools and plugins to do stuff for you, like create a new slide based on my text, things like that. The concept of function calls and tool calls are going to become more and more popular, and more companies are going to start looking at implementing these things. These are basically LLM telling you what to do. So your application gets feedback based on an input as to what function to execute, what are the parameters, and execute a bunch of code, right? Code interpreter is, which ChatGPT has, is one of those things where you can execute code as part of your LLM call chain. This is my favorite one. Being an engineer and developer, I love the JSON mode because this gives you more determinism, more reliable responses. Instead of just text coming at you, magic strings, you can actually use JSON mode to, have it construct the schema that you want. Reasoning over data is going to get really, really popular. One of the questions that you asked, personalization, is going to play into this. NL to SQL, some people believe this is a solved problem. I don't think so. We will see. This is basically converting natural language queries into SQL queries so that you can then execute them on databases, right? It seems like a solved problem if your database is relatively simple and your schema is not that large and things like that. But the moment you have a very large system, things become very complicated. Aggregated reasoning, this is again future problem. This is basically saying I have a whole bunch of content that is similar, but give me a response that takes into account all of them. Retrieval fails there because retrieval only gives you a handful of responses that you can use to then call the LLM, right? But if you want an aggregated response, which has to take into account every content item that you have, then it becomes problematic. That's all I had, because I do want to spend some time with Q&A.
I got a couple I'll take from online first, then before we get to folks in the room.
Can I wrap up this?
Oh, you almost, sorry. Yes.
Yeah. So you can reach me on X and LinkedIn. And it's a tax day today. So file your taxes with Block. Right?
Oh, your slides are going to be there on like.
All right. Get some questions.
Yes.
Okay. Alex asks, were you able to achieve 100% accuracy with customer-facing responses using those guardrails? Was there a most effective method you found for filtering out incorrect responses, or is it a combination of several approaches?
I would only say that we are on journey to 100%. We're not quite there yet, which is why I wanted to share all these learnings, because you have to interact with, other people who are doing similar stuff to learn the new techniques and figure it out as you go. And as things are evolving, you have to try it. There's no other way.
A related question that Igor asks, how do you go about protecting from jailbreaking?
Use Azure OpenAI. First step. There's more to do, but that's the first step.
Any questions from the room?
I see that. I haven't seen that option, Azure OpenAI, though.
Oh, yeah. If you go to the Azure AI Studio, there is a option there.
Okay.
So I have a couple of questions because I came late. The difference between embedding and fine-tuning, I thought they're the same.
No.
When I see the architecture I have, you load data during the design time
Yes.
to feed your LLM, and my understanding that's fine tuning, but it says embedding. They are the same or they are different?
They are different. Embedding is basically taking your content and turning it into vector representation, which you can later query on. Fine tuning is preparing a data set that literally looks like Q&A, right? You have to prepare your own data set. That is not your content, but here's my question, here is my answer. So you're basically preparing data set and fine tuning the model. So you have to do it, and it's of course expensive and time consuming compared to embedding. Embedding is a much simpler process. Fine tuning is a little bit harder and takes manual labor to prepare that data set.
But both help to teach the model about my data.
Correct.
Okay.
Embeddings are stored on our side or it's on LLM side?
Depends on your architecture, but in a regular application, you store your embeddings in your vector index. Like in case of Azure AI Search, that's where you store it. Or you can store it yourself in files, right? That you can do. You can store it in blob store. You can store wherever you want, but in runtime, you want to be able to query them.
And the cost structure for embedding? Is the one-time cost to embedding?
Every time you run embedding process, it costs. Yeah. Unless you go with some other, managed models. I don't know about embedding, what managed models Microsoft has. Maybe Microsoft folks can answer that.
The typical pattern is using Azure Search to do the embedding. Who is asking the question? Yeah. Typical pattern that you saw in the reference architecture that Vin had up is to use cognitive search or AI search now, and then load it up with your stuff and configure it for those embeddings, and it will make them periodically. So it's included in you asked a question about costs. It's included in the cost then of running and using the search service as part of the application.
Awesome. Thank you. Second question I have about, remember the 1, 2, 3 has number 1, the statement, number 3 is the prompt engineering. What's the difference between prompt engineering and the statement? Shouldn't be the same. I thought they are the same. So prompt engineering to write the sentence correct to the model to the answer.
Yeah.
And the statement, I need to change the user statement to something that the system answer. Goes up to state.
Are you talking about system prompt and user prompt?
Can you go back to the slides for 1 to 3?
Sure.
Thank you. Yes. Here is the application restatements.
Restatement?
Yes.
Okay.
Compare between it and the prompt engineer.
Oh, so restatement is basically taking the user input question and making it more suited to your use case, because not always the user input questions are like these are entered by humans, right? So they may be short, they are not enriched enough. So you may apply some techniques to enrich it, to make it do better retrieval, so that your eventual response when you get from generation is much better.
Why don't you ask them, do you mean this or do you mean this?
You can, yeah.
Yeah.
So what is the prompt engineering?
Prompt engineering is the whole thing. You see this diagram that I showed you? So basically figuring out what your base prompt is. How does the relative passages the whole like you have to think about the whole thing. So if I go back to this slide, see, you have to think about persona, tone, guardrails, variables, all these things. This is, things that you care about for prompt optimization, which is part of prompt engineering. But the restatements are simply a technique to improve user input. That's it. Yes.
When you create your embeddings, do you tend to include the system context in addition to the user prompt? Because you might change your system context over time, and that your embeddings that you saved in the past are sort of on an older version of of the system prompt. Is that ever a problem? Like, do you have to clear out your embedding database every once in a while as you tweak?
No. If the content changes, you have to refresh your, index. But, there's no side effect of
Keeping some older content.
If that content is relevant and if a query comes that requires that content, then you want to keep it. But if that content is outdated, then you want to take it away.
But you wouldn't probably embed the examples that you include alongside in your RAG, that the similar relevant examples, you probably wouldn't embed that, because that's separate.
You should. I mean, if it's like FAQs, right? Frequently asked questions, you can embed them too. Like, there's no problem. They may help you actually.
Ethically, what are you kind of thinking about in terms of kind of the differentiation between fact and opinion? So fact, when do I file my taxes? April 15th. Opinion, who is the best at filing my taxes? H&R Block. But if you're feeding both back to the user as this is the answer, obviously in this case it's a bit of a normal, but in certain cases, wouldn't ethically you'd have to be kind of saying, well, the buy label kind of preventative has kind of forced you down to this road where we're just going to say H&R Block is great, these are the products that we've got, but it's an opinion-based response there, whereas the rest are factual. And I can imagine that there's going to be, certainly when you're kind of using this for legal responses and all of these kind of things, that there's going to be a bit of an ethical kind of gray marker there in terms of, so how is the industry looking at this differentiation between fact and opinion?
Have a good answer for that question.
Okay.
Because I don't know. No idea. The only thing I would say though is if your enterprise content has the, fact or opinion that you're comfortable sharing with your client, then it doesn't really matter. You want to share it.
Right? If somebody has to make a decision based on that information, like for instance, what's the best formula to feed my baby if my baby is kind of suffering from thing, and you're sponsored by a certain formula manufacturer, you're only going to say that formula is irrelevant, whether it is best. At that stage, then it might actually be detrimental. So you could then, right? Yeah, but are these things not kind of opening up a case for kind of core cases kind of going forward, and where we have to kind of make that differentiation between saying this is an opinion and this is a fact at some stage. So the more we're trying to make them human, the more we have to kind of say, well, actually, this is a opinion-based response. And
maybe there are tags. You can probably tag certain content with fact versus opinion and
share that to the user.
Yeah,
that's kind of thing.
Yeah, that's totally a valid.
Rational agents concept in AI where it makes decision based on the logic and reason. There's another concept of irrational agent to set up. They have different use cases now, but in this case, it make the best decision based on fact and reason to make the best possible outcome.
Okay, but okay. Still be a little subset of data effectively. It might not use the entire algorithm.
But great question though.
Then one of the things I like about the story is that this is a true story. You started less than a year ago.
I've lived it every day.
Could you share with those here, like, what would be the dream team for a large language model project? Like, should you have a cross-disciplinary group of people, or should they all be from data science?
Great question. I would say most of applied GenAI is engineering work. However, that's not the whole story. You do need data people, data scientists, machine learning engineers. In the areas where engineers, like regular software engineers, may not have that expertise in, like you asked about ADF, right? Figuring out what to do about that data once you have it, right? That requires specialty expertise like data science and machine learning. And if you look at some of the problem spaces, like the bi-label classifier, for example, you may need machine learning engineers to build a model that's specific to your data set, your use case. So I think it's a very unique kind of a team that has application software engineers who know how to build apps, that requires product people who bring sleep LLMs. They need to really know what to expect. They need to know, what works, what doesn't work, things like that. You need a very good program manager who can manage, keep things tight, right? Because there are lots of experiments happening. Anything funny that you want to share?
You need subject matter experts also.
Of course.
Dealing with taxes, so you need people that know taxes.
I was going to come to that. So you do need a group of human-in-the-loop testers who are domain experts in this area, whatever that is, because they're probably the best people to tell you whether the response was incorrect, partially correct, or completely wrong. So you need a variety of different kind of roles in this team, but the largest number of people you need in the testing space.
And to add to that, I mean, there's another group that really important, the feature engineer.
Yeah.
So with a vast amount of raw data, you want to be able to carefully select the right observations or right, feature sets so that your calculations and training doesn't exhaust itself on crunching through data that is irrelevant to your observation.
Yeah.
That's just another add.
Getting the right people in the right place and build this team, that's really, really important. And we've had some good success with, picking the right people and creating, these new teams like the testers, right? We call it the GenAI evaluation team, whose sole job is to evaluate, right? It's easier to compare than to create. So what I mean by that is sitting down and writing a perfect answer to a question way harder than having the LLM generate a response and then say, is it good or bad? How good was it? And then take those comments, take that feedback, and continue to improve your system. Figuring.
Questions? We've got one more online. Have you had an experience with interrogating structured data like tables with numbers and documents? Have you handled that in RAG or other methods?
That is a great question, but it's a research area. Next frontier. Figuring.
All right. I think we've run out of questions.
Yep.
Thank you. Thank you very much, Vin. Did anyone learn anything?
Figuring.
Be real world feedback and experience, the hard learned viewpoint. It's core to what this community is about. So yeah, really glad to have Vin come and talk to us.